Thank you very much, Mark. All right.
Right.
Well, good morning, everybody, and welcome to this special presentation of the Robotiq Palletizing Solution presented by Robotiq and the Knots Company. My name is Tyler Mays. I am the Channel Sales Manager at Robotiq for the Eastern United States. I am a mechanical engineer by trade, and I'm based just outside of Philadelphia, Pennsylvania. I've spent the last few years working in the automation industry, deploying Cobot solutions for customers just like yourselves. Today's agenda is really an introduction to not only the Robotiq palletizing solution, but also Lean Robotics. So we'll dive in a little bit to the Lean Robotics methodology and how to effectively deploy Cobots. We'll introduce the palletizing solution itself for a few minutes, and then we'll also be doing a live demonstration of Robotiq's online palletizing configurator. That should leave us just enough time at the end for a question and answer segment. And so today's webinar is going to run about 45 minutes. As Mark mentioned, if you do have any questions, please feel free to write them in the chat. And if we don't have a chance to address them immediately, we will address them during the Q&A session at the end. So I'd like to start off with an introduction. And Mark, please take it away and introduce the Knots Company.
Yeah, so thank you. Who is the Knots Company? We work in the New Jersey metro New York area. We represent a large number of products from pneumatics to machine guarding to robotics to safety, but with the intent of improving your business results. That's our main focus. That's what we do. That's our passion. That's why we come to work every day, because we want to help our customers and make them more competitive and make them help them thrive in the New Jersey, New York marketplace. We're located in Berkeley Heights, New Jersey. We're central to the region we cover, and we're able to get anywhere in a day's notice and less than that in some cases. And so that's a quick overview of who we are.
Thank you, Mark. And a quick overview about Robotiq. Robotiq is a hardware and software company based out of Quebec City, Canada, with the mission of freeing human hands from repetitive tasks. So that kind of company mission will be more apparent as we dive into more details about Robotiq's products. We were founded back in 2008, and all of our products are made at our headquarters in Quebec City, Canada. As we stand today, we're about 150 employees, and we have our headquarters in Quebec City, Canada. We have a location in Lyon, France. We also have a presence in the Asian market as well. So at the beginning, when Robotiq first started making products, we were making plug-and-play components to really simplify grippers in particular for collaborative robot applications, to help simplify the programming and offer flexible components for flexible cobot applications where we're going to be gripping a wide variety of parts and need some different functionality. As time went on and Robotiq has continued to come out with new products and new solutions, those plug-and-play components developed into application kits, like the CNC machine tending kit you see here on the screen. We also have kits for other applications as well, like sanding, surface finishing, polishing, etc. Now, very recently, as a matter of fact, this product launched towards the end of last year. Robotiq has gone into the application solutions category, where we're providing everything, not just in a kit, but as a near turnkey solution for your palletizing application, which we'll be discussing today. So I want to start off, before we go into details about the product, with a little bit of the methodology behind how Robotiq has been so successful in implementing cobots and automation over these last 13 years. So Lean Robotics is a methodology to help us understand the challenges in a robotic application. And we do understand that the challenge is not the robot. Robots are just about perfect at what they do, in that anything we tell them to do, they will do. But the truth is that in a true application, we see so many things that have to go on around that robot in the cell, and we have to account for these things in our design, whether it's programming, training, upgrades, etc. And so we understand that it is the cobot application that is the true challenge. Not just that, but also the know-how required to design, integrate, and operate that new automation equipment. So what is Lean Robotics? It's actually a book that was written by our founder and CEO, Sam Bouchard. And what it is a step-by-step guide and a set of project management tools to help you get started, whether it's your first deployment of automation, or if you've already deployed some automation in the past and you're looking to scale that up. It's really a catch-all skill set and a lot of things to add to your tool belt when you're looking to improve your manufacturing processes. This is available as a hard copy, so any attendees who would like to get a physical copy of the book are welcome to request it, either from myself or from the Knots Company, or you're also able to access the book on iTunes, Amazon, Audible, etc. So what Lean Robotics does is to break any automation project down into 3 phases: design, integrate, and operate. And we're going to go into a little bit of detail on each of those phases by way of showing you some helpful tips and tricks from the thousands of automation deployments that we have. So our first tip for everyone is to start simple. When we look at the graph we have here, on the x-axis, we go from a low impact to a high impact project, meaning it has a great ROI, it improves the ergonomics or a safety issue that we have on site. And then on the y-axis, we go from a project being very simple, the low-hanging fruit, if you will, for our automation projects, and then going up to the more complex. So our number one tip is to try and focus on these projects that are both simple and high impact. If we're able to knock those out first, we're able to see a quick return on our investment and also avoid a lot of the potential headaches that come along with deploying a new piece of technology. Our second tip really goes hand in hand with that first tip. By starting simple, we also want to keep it simple. Many of us are familiar with the concept of scope creep. When we all sit down at a table and we're trying to brainstorm how a automation project would really help meet all of our needs, and we start discussing, what is the basis of what we need to automate and what are some things that are nice to have. If we're able to stick to the minimum viable robotic cell and get that deployed first, we're able to avoid a lot of calendar delays and the scope creep that really results in an incomplete cell. And if we have an incomplete cell, that is creating zero value both for you and for the cell's customer. So we always encourage you to write down all of the components and all of the design pieces of that minimum viable robotic cell. You can do that by choosing your KPIs or key performance indicators. So some examples of that would be, how is it going to improve my capacity for manufacturing? How is it going to increase the quality of my manufacturing? Am I going to be able to reduce my scrap rate by automating a particular task? Am I becoming more efficient in how parts are moving through my manufacturing process? And am I possibly able to improve the excuse me, I always struggle with this word, the ergonomics, the ergonomy of the application. So going into a little bit more detail of those 3 phases of an automation project, the design, integrate, and operation phase, each of those have a finish line of sorts, where in the design phase, we're completed there once the plans and the equipment for the robotic cell have been finalized and equipment has been purchased. The integration phase begins as we start to obviously integrate that new equipment, and it completes once that robotic cell and the entire team is ready to operate. Now, once we're in operation, that doesn't mean our work is done, because in the operation phase, we're going to have to do a couple things to improve upon that. So going through the process, we want to start with a manual process definition, meaning we want to study what operators are currently doing today and make sure that we account for all of those actions in our automation. We take that then to a robotic process concept. And from that concept, we're able to draw comparisons between the manual process and our new robotic process. After that, we're able to finalize the robotic cell design. Now, I do want to highlight here a very important note in that in the manual and robotic process comparison, we do need to pay very close attention and make sure that we're accounting for everything that operators are doing to produce quality products. If an operator is palletizing, for example, but they're also doing a visual check to check for a barcode or the quality of the box, etc., we do need to take that into consideration and make sure we're accounting for it with our automation. Moving on to the integration phase, there's going to be a component of preparation before we introduce the automation to the production line. So we spend some time testing and validating there. We then have to prepare the production line to accept the new automation and then install that automation onto the production line. We also then have to train all of our employees, whether it's our operators or our maintenance crews or the engineers responsible for programming the cell, whoever is involved in that robotic cell, we want to make sure they're trained up before we hit the operation phase. Again, once the cell is ready to operate and the team is ready to operate, we go into that phase, and our work, again, is not complete because we need to go through a startup phase. We want to monitor how that startup is going, troubleshoot any bugs or issues that we come across. And then we want to make sure that we have a continuous improvement process so we can optimize the cell for cycle time, for example, or we can introduce some of those nice to haves that we identified earlier when we stuck to the minimum viable robotic cell. So our number 3 tip, and this one may come as a surprise, is that we don't start with the robotic cell design. We really do have to start with that manual process definition, and that is the key way to get to producing parts for the sales customer. Our number 4 tip is to de-risk as early as possible. So for any technical risks, you want to assess all of our unanswered questions. If we need to form a hypothesis about how this automation is going to work, we want to test that hypothesis and assign a confidence level to it. How critical are these technical risks to the automation cell? If it's a high risk but a very low impact to the actual production, then it's something that we want to consider, but we don't need to prioritize it as our number 1 priority. We then, once we've identified our risks, we need to figure out how to validate them and what is the cost to go through and de-risk those parts of the application. So our number 5 tip, and really the ultimate tip if you're looking to deploy new automation or potentially scale it up, is to standardize. Standardizing is the best way to avoid headaches and confusion and to have custom designs and differences between our robotic cells. For palletizing, for example, if we are looking to duplicate that cell across different lines, we don't want to have some sort of custom component, custom end effector, custom whatever it is. We don't want you to have to support different things. So standardizing is really the simplest way to make sure you're efficiently deploying your automation. Our number 6 tip comes in the way of encouraging you to groom your robotic skill. This quote is a little bit outdated, but the message behind it is not. In that robotics is the number 1 fastest growing skill of the quarter. That was back in 2017, and automation clearly has not gone away. So if we do have employees who are able to program and support our pieces of automation, we want to make sure we're keeping them engaged and really not looking to take their talents elsewhere. That's kind of the message behind this tip here. We've got so many good companies, so many large companies like Google, Uber, and Amazon that are able to snatch up some of the automation talent. So my recommendation and the Lean Robotics recommendation is to make sure we're fulfilling our engineers and our skilled workers who are able to support the automation and they don't take their talents out elsewhere, to put it frankly. Our number 7 tip and our final tip is in that monitor phase of production, where you want to monitor your key performance indicators. You want to track and optimize these things. And then, whether you need to improve that cell or you move on to the next project, you have the option. But really, we have the software and some tools to help you monitor, especially with Cobots, that production and look for areas to improve. So to summarize the Lean Robotics portion of this presentation, if we look above, that would be kind of a traditional automation project where we don't plan in advance and look to avoid the non-value added segments of a project, whether that's waiting for questions and answers during the design period, it's waiting for lead time, it's waiting for support during the integration phase. The more we're able to eliminate those non-value added components of an automation project, the sooner we're able to get that robot into production and the sooner we're paying back the return on investment for that cell. So without further ado, I'd like to go ahead and introduce the Robotiq palletizing solution. I want to start off by identifying that palletizing is not a unique application for robotics and automation. Matter of fact, it's one of the more common ones. I've seen stats that go as high as saying that 35% of robots are deployed in palletizing applications. But the problem, one of the problems that we face with an industrial palletizer is that it's not a flexible piece of automation. It does take up a pretty significant amount of space, and in today's manufacturing environment, floor space does come at a premium. If we have to make any changes to our manufacturing process, the programming and changeover time is incredibly time consuming on industrial robots. And in terms of the skill set and the knowledge base required to support this cell, outsourcing is almost always required in order to support an industrial palletizer. On the complete opposite end of the spectrum, maybe today at your company, you're manually palletizing, and that has its own risks. On the ergonomic side, manually palletizing does lead to repetitive, strenuous, and palletizing and repetitive, strenuous tasks lead to injuries, which we obviously want to avoid. Manually building a pallet is time consuming, and quite frankly, humans have better potential for more value-added tasks, to make decisions, to have more fulfillment in their job. When we see today that there's help wanted signs outside of just about every manufacturing facility, the job environment is so competitive and it's so hard to find and retain workers. The workers that we do have, we want to make sure that they're doing the best possible tasks for them. So that brings us to the Robotiq palletizing solution, and I'd like to introduce that with this short video. All right. So a quick introduction, and obviously that video covered a lot of different things, which we're going to dive into some more detail here. So on the specification side, you'll see that the Robotiq palletizing solution is able to handle a very wide variety of box dimensions and also quite a tall pallet height. On the box side, we're able to handle boxes as small as 2 by 2 by 2 inches. Technically, we're able to go smaller than that, but I'd be really interested to hear the use case. So if you are palletizing boxes smaller than that, I'd love to see the application. On the maximum side of things, the box dimensions can be up to the pallet size itself. So really, you're unlimited in terms of the types or dimensions of cases that you can handle. On the payload side, we are using a Universal Robots UR10, whether it's the CV series or an E series. So we're left with up to a 17.5 pound payload. We're also able to achieve up to 13 boxes per minute in terms of cycle time. On the dimensions, this is another area where the Robotiq palletizing solution brings a lot of value. I mentioned that floor space is always at a premium. And so you can see here both the metric and imperial dimensions of the palletizing solution of just the base itself. So that base is about 32 inches wide. And then you add 2 of your pallets to it to give you an idea of just how much floor space that takes up. It's about 8.5 feet tall and just about 5 feet long in terms of its full dimensions. We have not just the 2D dimensions, but also if you're looking to include the CAD in your floor layout, we have that available on the website. We also have a 3D model of the palletizing solution on our website as well. To highlight what's in the box or what's included in the Robotiq palletizing solution, to put it simply, it's everything but the robot. So we include the Robotiq base with that fully integrated vertical 7th axis. It includes the pallet sensors, the status lights. The gripper is included in the box, but it's also optional if you need to use another solution for some reason. But in the standard package, the Robotiq air pick vacuum gripper is included with brackets for 2 and 4 suction cup configurations, like you see in the top right corner of the screen. And we also include an extra reach bracket in case that is required to give you 200 millimeters of offset at the tool flange of the robot. The software behind, kind of the magic behind the palletizing solution is in the material handling copilot, which is included. And then we also included a number of accessories as well to help with the deployment. So we have the infrared box sensor to check the box presence at the pick point. We have an anchor kit to secure the palletizing solution to the floor, and also a cable management system. On the assembly side, we have a step-by-step instructions that are provided in the Robotiq palletizing solution manual. I'm not going to go through each of those steps here today, but it's actually a good opportunity for some input from the Knott's company because they do have one of these palletizing solutions at their facility. So Mark, Maria, or anybody else from Knott's on the call, would you care to comment on the assembly side of things and how easy this thing is to get out of the box?
Yeah, so it shows up in the box that you saw in the video there, partially pre-assembled. Steps are really clear on what steps to take on what you need to install, when you need to install it, and then getting it up and running was really fast because the amount of sub-assemblies that were in the box made it a lot easier, and the directions are very clear.
Perfect, thank you, Mark. And just another note to go along with this assembly slide here, we have also a e-learning platform where you can follow a video guide and follow along as you go through the assembly process. So once the palletizing solution has been assembled, we move on to the setup phase. To break it down very simply, you just need to move the palletizer wherever you need it on your production floor. You set up the program by inputting the box dimensions, the pallet dimensions, and then teaching where the pick point is. And really, once that's done, you're in the operation phase. You're able to hit play and watch your palletizer go to work. We're going to go through a demonstration of the Palletizing Configurator to give you a better idea of the programming side of things. And then I'll also make mention of it here. There's going to be another webinar and a live demonstration of that palletizer on March 4th. So please make sure to potentially add that to your calendar. So how the palletizing solution works in the operation phase is once you start your program, Material Handling Copilot is automatically generating and optimizing the robot motions with synchronized motion of that 7th axis for maximum efficiency. So to give you a better visualization of how that works, what we're doing is really optimizing on that path planning side of things. And our Copilot is automatically generating and optimizing the trajectory of the robot's path. To put it simply, we're controlling a 6-axis universal robot as a 7 degrees of freedom robot with that 7th axis. So you'll see that synchronized motion both in the simulation and when you see the palletizing solution live. On the production floor, we do include status lights to help really easily convey what the palletizer is doing. So if the robot is idle, it can be in any one of those 3 states there. If we have a red light, the PLC is disconnected, yellow light, etc. So all of the different colors and what that color indicates in terms of what the palletizing solution is experiencing, that's all available in the palletizing solution manual as well. But the truth is once the palletizing system is running, you're mostly going to see green stack lights, and then once a blue light is is shown at the top of the stack, that means that a pallet is full and it's ready for an operator to come swap it out. This is very useful, not just for diagnosing problems, but also for anybody who's going to be on the production floor interacting with the palletizer. It's an easy way to see the status from a distance without having to go on to the teach pendant of the robot. On the safety side of things, the Robotiq palletizing solution is ready for third-party safety sensors, such as safety interlocks, light curtains, or area scanners. In the case of the Knots company, Mark, feel free to provide some input here, but you guys are using the Leutze area scanners.
Yep. Leutze area scanners, as well as we can use some 80/20 framing if need be. Again, we do an assessment, and we kind of see how the palletizers are interacting with the environment, see who's around it, how high is it lifting, etc. So there's some avenues we can take to increase the safety of the application without taking away from the flexibility.
Mm-hmm. Perfect. And at the end of the day, whether it's a Cobot solution or any new piece of automation, you're always going to want to perform a risk assessment in order to ensure a safe implementation of your automation equipment. I also want to talk briefly about the safety behind the linear axis. You can just see here on the details of the screen, we're able to change the linear axis from one category to another, depending on what the palletizer is experiencing. So if we e-stop the palletizing solution, for example, there's a safe torque off motor with a brake in it to completely stop that 7th axis and prevent it from sliding or causing any sort of accident or injury. One of the really important things to highlight about the Robotiq palletizing solution is if you do decide to implement it in your production, the shipping and lead time is just about as fast as it could possibly be. In the United States, from an order to shipment is 5 business days. The solution is packaged in a custom crate, and that crate is also used as a part of the setup process. So it's kind of a tool in and of itself. And the typical transit time is between 5 and 7 days. So if you ordered your Robotiq palletizing solution today, you'd be seeing it in 2 to 3 weeks, which in today's supply chain and lead time issue environment is really impressive, in my opinion. On the support side, we have all the documentation to go along with the product, and really all the documentation you would expect with a Robotiq product. So we have a full product manual and a quick start guide available on the website. If you're unfamiliar with the risk assessment process, we do provide a template that you can follow along with to get a better idea of how to create a safe deployment. The UR caps for both the material handling copilot and the gripper are available on the support website. And I'll mention it briefly now, but we're also going to take a look at it in a few minutes on the e-learning side of things. Not just for the palletizing solution, but for all of Robotiq's products, from our grippers, our camera, our force torque sensor, and everything else. We have a full e-learning platform with courses designed to take you from basic installation all the way up through advanced programming, and those are broken down in 5-minute segments. For after-sale support, you can always contact support@robotiq.com, or for application support, if you're currently evaluating your application for automation and you're looking for some input from the experts, get a coach involved and write to coach@robotiq.com. So with that, I want to jump over to the online palletizing configurator, which is really one of the most impressive and possibly dangerous tools in terms of looking at where we want to deploy these palletizers. So if you want to follow along, you're welcome to go to Robotiq's website. Right there on our landing page, you'll see information about the Robotiq palletizer, and you can click the link to go to the configurator. But I'll go ahead and go through a couple examples here on what a real pallet setup would look like. So to give some background to you about the simulator and the environment, there's obviously a lot here on the screen. We're able to work either in metric or imperial units. So I'm going to go ahead and switch that now before I have to try and figure out millimeters in my head. If you create an account for the simulator, you're able to save and share your projects, which is really useful if you want to share it internally with other members of your team. Share that with Robotiq for some input from our experts, or share it with the Knots company for their input as well. It's a very easy to use platform. On the right side of the screen here, you have a number of resources and tools that are at your disposal. So that introduction video that we looked at earlier is here. And then a link to the e-learning that I was mentioning is here as well. So this takes us directly to the Palletizing Solutions e-learning course. And you can see that this is broken down in individual lessons. So that introduction all the way up through installing the palletizing solution, deploying it safely, etc. Our e-learning platform is really in depth and encompasses all of our products, and it's a continuous work in progress where we're adding new content constantly. So if you're looking to deploy a cobot, whether it's for palletizing or really any other application, please do check out our e-learning platform to learn more information. These are meant to help you deploy the robots yourselves. Jumping back to the simulator here, I'm going to go ahead and do a quick setup with a very simple box case. So let's say my box dimensions are 10 inches on the front, 12 inches on the side, and let's call it 6 inches tall. And let's say, just for the sake of argument, that they weigh 8 pounds. I go ahead and include that. And the next step is to input my pallet dimensions. So I need to fix that rounding error once we went from metric to imperial. But a typical pallet size of 40 by 48 inches and a normal pallet height, just about 5 inches. So we'll go ahead and hit check on that. We're not going to mess with this yet, but we will in a second. You have the ability to adjust your conveyor and adjust where the pick position is going to be for the robot, and also the dimensions of that conveyor. I'm just going to leave that as is for now. And then the final step, both on the configurator and when you're setting up your palletizing program on the UR teach pendant and polyscope, it's really the same exact process, just on that teach pendant. So what I have to do as my last step is to define my box pattern. So I'm going to do a very simple pattern here where these boxes fit nicely and we're able to get a number of rows. Odds are I'm going to accidentally goof here and click and put one in the wrong spot. So if I do that, I just change from add to select, and then I can either delete that or I can just use the delete key. We're going to finalize that first pallet row. And if these are my boxes and that's my pallet, the only thing I have left to do is to tell it the number of layers. So let's say it's 12 layers. I hit check. And then what we're doing in the background with this simulator is using the same exact material handling copilot algorithm, to figure out what your key performance indicators are. So for this particular configuration of box dimensions, weight, and the pallet dimensions, you can see here that we're actually going to use the extension bracket for the robot to ensure that we can reach all corners of the pallet. And you can see also, this is the true motion that the robot will be following. So this is a real-time 3D simulation of your palletizing application. On the bottom of the screen, you get your key performance indicators. So on the process side, I'm running at 9.9 boxes per minute, and it takes 20 minutes, give or take, to complete a pallet. I have information on the pallet dimensions for a full pallet and its weight. And then I also see there my box information. You may be asking yourself at this point, well, that's great. What if my pallet is not quite that simple? So let's go ahead and create a more complex pallet pattern to reflect what your real world application may be. So let's say my box is 18 inches on the front, 10 inches on the side. We'll leave the height at 6 and we'll leave the weight at 10, or maybe we'll just go ahead and change that just to see how that affects our key performance indicators. So if I do want to make those changes, the simulator is obviously going to tell me that in my pallet configuration or my pattern configuration, I've got errors. So I do need to edit that. I'm going to delete all these quickly. And I can start fresh for a new pallet configuration that includes kind of a overlapping brick pattern. I'll do that one real quick, and then I'll also show a pinwheel pattern as well with rotated layers. So I'm going to be adding my boxes, and we're going to start here. I've got it on snap to boxes, but you can also uncheck that and kind of free place the boxes anywhere you'd like on the screen. But I'm just going to keep it like this to keep things moving quickly. I can rotate the boxes with my arrow keys or with my mouse, either way. And I'm going to put my final two boxes in place, and that's going to be my first layer. And let's say in my particular pallet, we've got different layers between each sheet. So I can go ahead and account for that both in my simulation and in my robot program. So I'm going to create my next layer by mimicking but rotating what I had before. All right. And let's say I'm still having 12 layers, but I want to alternate between layers. All I need to do here is determine whether that layer is going to be pattern A or pattern B. I indicate that on the teach pendant or in the program. If I want to, actually, I'm going to save the optional delays for the next one. We're just going to go through this real quick just to show the simulation with different layers. You'll see that the simulator it does take some time to think through that algorithm and come up with your program. But again, once that's done in a matter of minutes, I have now, kind of tested a proof of concept for a different pallet configuration. This is incredibly useful if I'm looking to deploy my palletizer for the first time, or if I've had a change in production and we need to account for, new boxes, for example. I can quickly validate and test that with a simulator rather than having to do that with my physical palletizer. It avoids a lot of complication and saves you on the design time with the complexity of things. Looks like we're actually coming up short on time here, so I do want to show those complications or the optional delays we can include in a simulation. Let's say that your pallet has interlayers or slip sheets between each one. So we would have 11. It takes the robot 12 seconds to go pick that sheet and put it in between, or I can adjust that to be whatever my actual process would be. And if I want to also include a pallet swap delay, just to see what my hourly production rate would be, I can include that as well. So let's say it takes 2 minutes for an operator to swap out a pallet. Once that information is input into the simulator, I hit check again, it recalculates, and my key performance indicators have adjusted accordingly. So again, I'm not sure if everyone has had a chance to try and follow along as I'm doing this. I know we're on kind of a tight time schedule, so I would encourage you to go to Robotiq's website and please do check out the Palletizing Configurator, so you can check your pallet configurations and see if this is a good fit for your manufacturing process. All right, that brings us to the question and answer section of today's presentation. So Mark and Maria, if you want to jump on as well and treat this as kind of a panelist type discussion.
Okay.
While everyone is writing their questions in the chat, I can go ahead and answer a couple of the frequently asked questions as well. In terms of Cobot compatibility, the Palletizing solution works with both the UR E series and CB series UR10s. The solution does not use the force torque sensor, so that's kind of useful if you have one version of the robot or the other, but that force torque sensor may be a valuable part of your application in some other aspect. So please speak with your representative at NOTS to ask a little bit more about that. The solution is compatible with MIR or really any AGV by way of raising the solution to the desired level. We can stack pallets on those AGVs and move them throughout our facility. There's currently no option without a linear axis. To put it simply, that's just because we can't reach a full pallet in most cases. But if you do have a use case where you don't need that 7th axis and your pallet can be reached with a stationary robot, let's talk about it. The palletizing solution is compatible with all of Robotiq's grippers, but also any other gripper brand, and we provide guidelines on how to use those in our product manual. Interlayers can be accounted for with a between layer node in the robot program, so we have a solution for that. On the label orientation side, we're able to do it on a case-by-case basis right now, but in terms of it being added to the UR cap that is being released this quarter. Our e-learning, as already mentioned, is available and a continuous work in progress. If your application requires 2 conveyors, we can absolutely handle that with a 2-pallet node. Let's talk about that offline if you do have a 2-conveyor system, and we can show you a little bit more in depth on how that would be worked. And if for some reason you have a need for a custom box sensor, one use case, for example, with the Knots company is that a customer needed to stack the, let's say it was green labeled boxes on one pallet and the blue labeled boxes on the other. If Robotiq's sensor that's included in the kit does not work, we could use a color sensor, for example, to validate that and then incorporate that into our robot program. All right, oops. So with that, Mark and Maria, are there any questions from the group that we can help address before we talk about what the next steps are?
Yeah, sure. We have about 8 questions here. So we'll work through them as they come along. I'll read the questions, and I think this first one, Maria, you're going to answer this first one. Can you modify to increase weight max to 35 pounds?
So for specifically right now, because we're using a UR10, so it's designated by the payload of the robot. So the payload of the robot for UR10, the maximum is 22 pounds. And as Tyler indicated in his in one of his slides, the maximum could go up to 7.5 pounds because it has to take into consideration the gripper itself. So,
all right,
so currently there isn't a modification to increase it 35 pounds.
Mm-hmm. And on the Robotiq side of that question, we're evaluating if it's possible to work with some assisted lifters or other kind of assisted devices with the setup as it is. But to put it simply, right now we have not identified one that can give us a payload well above and beyond the UR10's capability.
All right, thank you, Tyler and Maria. Next one up, can you palletize 2 separate boxes on 2 separate pallets at the same time?
Yes, you can. I would encourage you to do that with 2 different conveyors, but if it's not possible, there's kind of a workaround. So let's take that conversation specific to your application. But yes, with a 2-pallet node, you're able to palletize one type of box on one side, one type of box on the other.
All right, next one. Does the box to be palletized on the roller conveyor need to be firmly positioned, or does the robot see and adjust?
Great question. No, we do want to pick from a repeatable location. So in some cases, the conveyor inherently does that. But for a real world deployment, we would want to use something like rail guides or maybe some sort of pushing device to seat the box into a corner for picking. We could potentially evaluate using the camera system or maybe even Robotiq's wrist camera to see the boxes. But the truth is the simplest and most cost-effective way to solve that potential risk to the automation is to get the box in a repeatable pick location.
Okay. So we have 5 more questions. We'll try to squeeze these in. These are great questions, so thank you for typing them in. Here's the next one. Does the software take inputs from barcode scanners to determine the pattern?
No, it's not designed to do that, but you could. Well, this is the fun part about automation. Yes, we can do that. It's not able to do that out of the box, but with some a little bit of work, we could do it that way to trigger the robot program based on which barcode we read.
Right. Next one, assuming we could create designated standard box sizes and assuming we could create designated standard box sizes and various preset configurations. Like to continue that, like multiple programs dependent on the box.
Yes, absolutely. And so, just to give an idea of what that would look like on your production floor, if I'm running a shift of one particular box for 8 hours and then I need to change over for the next shift, it's simply a matter of selecting the other robot program on the teach pendant. Or if we're doing something with a barcode scan, for example, it would be handled that way. But out of the box, it's just a matter of selecting the program on the teach pendant.
All right. Next one up. Can you save programs once made to be used at a later date?
Yes.
Yes. All right. Next one up here, slip sheets. How do you pick them? Do you pick end of the slip sheet and drag, and what is the slip? What if the slip sheets stick to each other?
Yeah, great question. There is no one answer that accounts for every single application. It's kind of a formula of the floor space you have available, what the slip sheet is, whether it's a paper slip sheet or cardboard slip sheet, whatever. So there's going to be a custom design of how to solve that. But to simply put it, we're going to want to put those slip sheets in a stack, and typically we'll angle them as well to be able to do a bit of a hybrid to drag and pick that sheet and ensure that they don't stick together. We've tested slip sheets in a number of different ways, and in just about every instance, we've been able to handle it and pick those one at a time.
All right. Thank you again, Tyler. All right, 3 more questions I have in the box here. What is the utility requirement, air or power?
Great question. Yep. The power requirement is it plugs into the wall, standard 120 volt AC power. So there's no need to drop a special power connection in most instances. On the air side of things, if you're running typical standard air pressure anywhere between 80 and 100 PSI, that is where Robotiq recommends. So in terms of power and air requirements, you need that 120 volt power supply and the 80 to 100 PSI compressed air.
Right. All right, 2 more. Another one popped in here. How many programs can be saved?
Virtually unlimited. I don't know of a reason why there's an upper limit to the number of programs that could be saved. There is no limit in practicality.
Yeah, I mean, even from the UR standpoint, I don't think I've ever. I mean, I know with our demo robots, the number of programs on there is very high. So I've never seen anybody hit the limit on that side. All right. Next one. What's the ballpark cost of the solution?
Yeah, another great question. So it's going to be dependent on your actual application, but in terms of simply the Robotiq solution and the robot out of the box as is, you're looking well beneath $100,000.
Perfect. All right, last one we got here. Can you make a copy of this meeting available to share with others in our company? And the answer to that is yes. I'm recording the meeting, and we'll be sending this out to everybody who attended, as well as others who unfortunately couldn't attend today. And our emails, contact emails right there. As we go through it too, you'll see Maria's contact information. So yeah, this will be readily available, and you can share it internally.
Please consider joining us for our next webinar on March 4th at 11 a.m. That is going to be a live demonstration of the Robotiq Palletizer. So obviously you can't all click this link here in the presentation, but it will be shared with you shortly.
Right.
The contact info Mark mentioned for both Maria and myself.
So another thing just to mention, we do have, like Tyler mentioned, we do have the palletizer in-house. So if there's anyone who's interested in trying to see if you would like to ship some boxes to us, and we could do a configuration, and we could do like a remote live where you could see how the setup is done and how the boxes are configured as well. So if you want, we could have that available in March, or for the actual webinar.
Good, thank you, Maria. So with that, we want to leave you with one final message: to start production faster, start palletizing faster, and start your project today by trying out the Robotiq Online Simulator. That concludes.
Thank you.
Yeah, go ahead,
No,
Mark. You can wrap it up.
Yeah. No, thank you, Tyler. Appreciate going through that. Great amount of information. I just want to say thank you to everybody who attended, and thank you for those great questions. Feel free to follow up afterwards if you have any additional questions. And again, thank you for your time. We really appreciate it.
Thank you.